Hi guys, welcome to the channel. This is the 5th video of the shader development tutorial series. In this video, we are going to add texture to our diffused shader. And we will also be looking how to apply lighting to our objects. But before going further, I must recommend you to watch the previous shader development tutorial if you haven't watched them. So till now, we have created a custom diffused shader, and we have successfully projected the shadow. Before starting the tutorial, let's have a look at the final result. In this final shader, we have a texture, environmental reflection, and the shader also have a diffused lighting. This shader also reacts with the fog. First, I am going to comment all the code that is used to cast shadow. Once we are done with everything, we will enable the shadows again. Firstly, we are going to add environmental reflection. For doing this, I am going to write a property to get the normal maps. The name of this property is bump maps. The type of this property is 2D and default value is bump. Then in v2f struct, we have to define some new variables. The first variable is a float, 3, world pose, the type is text core 0. The second variable is half, 3, t space 0, the type is text chord 1. The third variable is half, 3, t space 1, the type is text chord 2. The fourth variable is half, 3, t space 2, the type is text chord 3. These three variables are the 3x3 world matrix. They transform tangents to world space. Fifth variable is UV. And the fourth variable is pose. I will be going a bit faster in this video because I have already explained most of the stuffs in previous videos. Now, I am going to define a new struct, appData. This struct holds all the informations about the given mesh. In this struct, we are going to define a variable vertex with type position, a variable normal with type normal, a variable tangent with type tangent, and a variable UV with type text chord 0. Then invert function, pass this appData struct as argument. Now in invert function, we have already defined a v2f variable O. We are going to say o.pose equals Unity object to clip pose and pass v.vertex in it. Then write o.worldPose equals multiplication of underscore object to world and v.vertex. Then take their xyz value. Then define a half-3 variable w normal and calculate world normals by doing Unity object to world normal, then passing v.normal in it. Then define a half-3 variable w tangent and calculate world tangent by doing Unity object to world dir, then passing v.tangent in it. Then define a half variable tangent signed and set it equals to v.tangent.w multiples with unity_world transform params.w. Then define a half-3 variable w by tangent, and its value is equal to the cross product of w normal and w tangent times tangent sine. Then set o.t_0 equals to a half-3 variable whose x value is w tangent.x and the y value is w by tangent.x and the z value is w normal.x. Then do the same for the rest. Then write o.uv equals to v.uv. Finally return o. Now include the bump maps property. Remember that the textures are defined using sampler2d. In frag function, define a half-3 variable t normal and then unpack the normals. Then define a half-3 variable world normal. The value of world normal.x is equals to the dot product of in.t_0 and t normal. And similarly, for the y value, we will use t_1, and from z we will use t_2. Then we will define a half-3 variable worldview direction. The value of this is equals to the normalized value of Unity world space view direction. Then we will calculate the reflection by using the function reflect. This function is included in the Unity3d library. We will pass negative of world view direction and world normals in it. Sky data is also calculated. Sky data is a half-4 variable. It is calculated using Unity sample text cube, and we pass Unity spec cube 0 as argument. Sky color is calculated from sky data. We use decode HDR function to calculate the sky color. Then we define a fixed for variable C. Then we set the RGB value of C to sky color, and finally return C. Save the shader and head back to Unity. You can see that we are having some errors. First error was that I added colon instead of semicolon in line 34. Second error was in line 28, where I wrote T_3 instead of T_2. Now you can see that our shader is working as expected. It is reflecting the environment. Now we will add texture to our shader. For adding texture, I am going to define a main texture property. The type of texture is 2D and default value is white. Then include this property in sub-shader block. Remember we use sampler 2D to define textures. Then in frag function, define a float3 variable, base texture, and set it equals to text2D and pass main texture and UV as arguments. This will apply the texture on the mesh by using the UV data. Finally take its RGB value. Then write c.rgb equals to the base texture times c.rgb. Save the shader and head back to Unity. You will see that the objects now have a texture. You can change the texture by selecting the material and using the material slot in the inspector. Hope you liked this video and learned something new. In the next video, we are going to add diffused lighting and ambient lighting to our shader. We are also be making our shader compatible to fog. So stay tuned for more shader development tutorials. Please drop a like and subscribe to the channel for more Unity tutorials.